Good morning, everyone. Chris Smallcomb with the National Weather Service in Reno. A lot of you know me through presentations and the freakout chart and briefings we do for the area. So what I'm going to do in this presentation is talk about what we know and what we don't know for the coming winter outlook. Obviously October was big, November was a dud, December, then there's some signs for optimism here in the coming couple weeks, and I'll talk more about that. And then just some resources for weather information in the area, specific mainly to avalanche and winter storm type stuff. So, and then I'll take any questions. As I go along in the presentation, feel free to just chat questions. I won't necessarily see them live, but when I'm done, then I will have that to kind of go back to. So I'm going to go ahead and share my screen here. I'll just share the entire screen there. And there we go. And there I am running in questionable air quality, like a lot of us had to deal with this past summer and last summer as well, in 2020, especially. You guys had the bad 2020. We had it pretty gnarly up here in 2021. So drought, fire, smoke, heat, just seemed like that was the theme of the year, coming off of another dry winter. And so is this coming winter going to save us all? And so that's the subject of the presentation. Now, this is sort of random. I do my fair share of run commuting into the office just to get some extra miles in. And lately, I keep finding all these boats along the trails. And now, when I say keep finding, I mean like 2 or 3 realistically. Usually I'm used to finding shot up, burnt out trucks or mattresses or things like that. But boats are something a little different. So does this mean something? Is this one of those premonition type things that I should be paying attention to that's not science-based at all? Does this imply it's going to be a very wet winter and we're going to need these boats to get around? 2017 all over again? Or is it going to be a significant drought is going to continue? And so people are just abandoning their boats because they just have this third instinct of like, oh, I'm just not going to need it anymore because everything's going to be dried up. Who knows? Well, let's get into some actual numbers and weather here. And we're going to start off with that super duper mega atmospheric river that really just put the hammer down on finally ending that hot, dry, smoky summer that we've had. And it was, I think, for a lot of us very welcome because the last couple autumns have been very dry well into November and even early December. And so it was nice to have a good big storm early in the season. Psychologically, it just helped to be like, okay, finally fire season largely done. We got water, things just sort of look a little more alive. And, I saw that out on the trails around here. You can see even a little bit of green up in some of the hills. And so here's a park in Reno Sparks. The porta potty there was not having a good day during the heavy rainfall event. But by and large, it was a very beneficial atmospheric river. We had only fairly limited flooding problems because the soils were so dry. This is largely a very beneficial AR event for us. And this is a picture taken the day after down in the Carson Valley near Minden Gardnerville, and you can see the flooded fields there with the snow-covered mountains reflecting on that. And so that goes to a point is that this storm really did saturate a lot of the ground in the Eastern Sierra, especially north of Bishop, where flooding could be a potential concern if we were to get some additional warm storms, those warm Pineapple Express atmospheric river type deals in the near future. Fortunately, and as I'll talk about, it seems like the storms that are coming down the pike would be of the colder variety. So here's a satellite animation. Hopefully it comes across okay. Sometimes on Zooms it may or may not, but it shows you the big storm. Shows you the atmospheric river, the stream of clouds all the way from Hawaii, slamming right on into the west coast of the U.S., Northern California, the Sierra, into Nevada. And so this storm was remarkable in that it just had a tremendous amount of moisture and also wind energy. And that's how we define atmospheric rivers, is we multiply essentially those two parameters, moisture and wind energy, to define how strong an atmospheric river is. And so by any definition, this was a strong and somewhat unusual atmospheric river, but for so early in the storm season, it was extra unusual. In fact, in my time here since 2007 in Reno. I have not seen a storm this strong this early in the season. This is more reminiscent of the types of ARs that we got in like January and February of 2017. They're just phenomenal amounts of moisture with those. So that was what was different about this storm. Again, so strong for so early in the season. So essentially, I kind of call it hitting the environmental reset button. Now, I have some Eastern Sierra stats here in a moment, but a couple of things closer to where we're at here is that Lake Tahoe, 191 square mile lake, it rose a half a foot. So that is a tremendous amount of water. And it's only the 8th time in 120 years that Tahoe has seen a net rise of the water level in October. So again, unusual early season major storm. Here at Reno, we have a very long period of record on the precipitation back to 1893. And this is basically set the record for the most amount of rainfall in a 2-day period at 2.92 inches. In fact, at my house in Sparks, which is typically even drier, we had nearly 3 inches of rain at the house. And this almost matched the total for the entire water year that we saw the preceding 12 months. So it just tells you how dry that water year was, but it also tells you just how big this storm was. And we saw very similar statistical comparisons all up and down the Sierra, especially on the east side. This storm was a big one on the west slopes, to be sure, but it was even maybe compared to climatology, even more remarkable on the east side. The spillover was very efficient. The rain shadow was almost non-existent with this storm for most areas. So for the east side, this storm was even more unusual compared to climatology than it was for the west side. It's still a big storm in any stretch. So these are some specific numbers for the Eastern Sierra, mainly focused on Mono County and very far northern Inyo there around Bishop. And you can see some that stand out to me, like Crestview north of Mammoth at 5.5 inches of water equivalent. Up by Sonora Pass, 9 inches of water equivalent. A lot of that, of course, was snow. Bridgeport, 1.8 inches. Even at Bishop, close to 3/4 of an inch of rain there. And remember, Bishop averages only 4 inches of rain per year. So that's still a non-trivial percent. Here at Reno, the rainfall was 40% of our annual total. There at Bishop, roughly a quarter of the annual total just in one storm. Now, specifically, I had to pick one spot to do some comparisons. So I picked, how about Bodie? Let's give Bodie some love. So 2.22 inches of precipitation there at Bodie. It was the 25th highest 2-day total since 1963. So decent, solid, notable. But if you just look at October's, it was the highest 2-day total for any month of October in the period of record. Again, goes to show just how impressive this storm was for so early in the storm season. So does this help the drought? Yes, but we still need more of these storms. The drought, one storm does not end a drought. Oftentimes one winter does not end a drought. We need, kind of multiple good winters to really put the kibosh on the drought, unless you have a winter like 2017. Then it can be just one winter and then boom, drought is essentially done. But of course, look at us, only a few years later, we're right back into it. Where this did really help the drought is the soil saturation. This I already alluded to with some of those photos I showed earlier. We went from near record low soil moisture levels in the Eastern Sierra at the Snowtell sites to record maximums that have actually lasted for some time. This is a fairly recent graph. And, November was really dry, yet the soil remains quite moist, especially where the Snowtell stations are. And so this does indicate that our flood risk would be a little bit elevated if we were to have any warm atmospheric river events in the near future. It won't take necessarily as big a storm to cause flooding problems in the Eastern Sierra. But on the flip side, on a very positive note for us, is that when we build our snowpack this winter, and then we start melting it off in the spring, that melt will run off into the creeks, streams, rivers, lakes much more efficiently because the ground underneath that snowpack is already going to be moist. The previous couple winters, we've had a snowpack, but the ground underneath it's been so dry because we did not have that key early season rain event to moisten the soils up. So it essentially acted like a sponge and it just absorbed all that snowpack as it melted off instead of it running off into the creeks and rivers. So as an example, this last spring, let's say we had about 60 or 70% of the annual average snowpack, but we only had about 50% of the runoff, as an example, just putting some numbers out there. Whereas this coming year, it should be a little bit closer. And that's good. That's some good news for our water supply and the creeks and the ecosystems and everything like that. So this is a storm we needed. And yeah. So fast forward a month, of course, and things have turned decidedly different. This is a little Instagram post I tossed out there. It's like my daughter Savannah, my son Carson. She's just totally leaving Carson in the dust on the trail there. And so I was like, oh, well, there we go. There's our winter. Drought's kind of winning right now over an actual winter. And so, admittedly, when that October storm happened, I had this. It just seemed like the atmosphere was behaving differently at that point. And like, man, okay, some optimism that we might have a busier winter season. And then, of course, November just sort of shut down. That ridge of high pressure parked itself over the West Coast, sent all the storms up into the Pacific Northwest, where they don't really need anymore at this point, especially up into British Columbia. But the winter's a long period. Winter is essentially 5+ months in the area, so we got a lot of time. And so, but November did take a toll on the snowpack here, especially that top diagram that shows the snow water equivalent on the in the Eastern Sierra snow tells on average. That black line there is now below the green line, which is the normal, the snowpack trend line. So we are at about the 37% of the median for this time of year. The running total precipitation, though, remains well above normal. Now, of course, you can't go down on that. Once you accumulate, you've accumulated it. So this is the rain plus snow, that big jump there in October from the storm that we had. Honestly, we're at where we typically would be around New Year's in terms of the running total precipitation. So in that respect, we're good, but the snowpack has suffered as a result of the relatively dry and mild November. So what does that mean? Does that mean anything? A wet October plus a dry November. Does that statistically mean anything? Can that parlay into something to say what the rest of winter is going to be like? So what I did is I created a chart here. It's a bubble diagram. Now, my Excel skills are a little rusty, a little dormant, and so I had to do a lot of research on how to create a bubble diagram. So bear with me. But what you're going to see here is I'm comparing the October precipitation at Reno. Again, it's a long period of record station, longer than Bishop and other sites in the Eastern Sierra. So it's pretty representative of the east side of the Sierra Nevada. So the horizontal axis is October precipitation. The vertical axis is November precipitation. And then what you're seeing here, each of these is the precipitation for the rest of winter. The bubble size indicates how big that was. So the dry rest of winters are in yellow. The wet rest of winters, so basically December through March, are in green. And the really big ones for December through March are in the blues. Now, of course, the standout here is 2017, where we had a very wet October, but a very dry November. And that went on to be one of our biggest winters on record. Now, the current winter would be somewhere out here because we had a little over 3 inches total in October at the Reno airport site. So, but does that mean anything? Unfortunately not. There's a lot of scatter here. You can't really say, okay, just because we had a very wet October and then a dry November, that doesn't really relay to anything. There's been plenty of examples where actually the winter kind of closes down and ends up being kind of dry for the rest of winter, although it's been a long time. A lot of these are close to 100-year-old winters. There's been others where they've continued on wet. So unfortunately, I don't think there's a really robust statistical correlation there. Really can't draw any conclusions from it. The one thing I will say, though, is if you notice a lot of these green bubbles here, which again indicate the really big rest of winter, so the really big December through March periods, oftentimes seem to have dry Novembers. There's one exception here. I think it's 1914 there, had a wet November after a very dry October. But otherwise, a lot of these end up having fairly dry Novembers, which is interesting. I don't know if that's a thing. But again, it's not a necessary condition. We've had big winters without it, and it doesn't guarantee, just by having a dry November doesn't guarantee any particular outcome. So I thought I'd show that statistical information there. All right. So let's talk about the winter outlook. Let's start with the predictability, ranging. We're going to start talking about, specific information out to monthly information for the winter outlook here. So I always like starting with this. You all remember how you do your March Madness brackets. That's about the only time I get involved in sports, except running, of course, is doing a March Madness bracket, because I literally know next to nothing about basketball. So I'm like, why not? Let's see if I can do this, which it always fails. So here's a couple interesting statements for you to ponder. All weather forecasts are wrong, but some are useful. I think a lot of you could agree with that, because you're given a weather forecast and maybe you're in a different part of town, or you're sometimes even just on a different side of the block or a building, and the weather is totally different than the other part of town, for example. So you might think, oh, that forecast was totally off. So everybody always can find something off about a weather forecast, just again depending on their precise location. So how can we make them useful though? Can we make them, they may not be precisely accurate, but can they be useful in terms of giving you guidance that might lean you in making a good decision? So that's where probability information, scenario information, what's the likelihood of getting enough snowfall to potentially close down the road, something like that. That's a useful weather forecast. Whereas just me going out there and saying, yep, there's going to be 2 inches of snow tomorrow on Highway 395, and there ends up being 5. Well, that didn't really work out by being that precise. But if I gave you a probability of that, say 5 inches occurring, that might be more useful guidance to make a decision based on your risk tolerance, your risk threshold. So that's a direction we're going in the Weather Service, is by providing that extra content in a lot of our briefings and information, is that probability and scenario type stuff. And you'll see that here in a moment with the forecast in the next couple of weeks, which is a perfect use of that kind of information. Here's another one. Forecasting anything beyond day 3 is about being a good statistician. Closer in, it's about being a good meteorologist. So this is another culture change that we're enduring in the weather business, is that realistically beyond day 3, you've got so many models out there, and there's so much possible forecast error, that doesn't really matter where the cold front is, doesn't really matter where the AR is. It's about interpreting where what the models are showing you in a statistical framework, so that you can provide that probability, that scenario type information. Of course, it's always important to know why things are happening, always, regardless of how far out it is. But the statistics are more important in providing a useful weather forecast, especially when you're beyond day 3. Now, closer in, that's where being a good meteorologist and having a good education and a good skill and experience set as a meteorologist matters, especially here in the Eastern Sierra, where the nuances, the windy areas, the cold areas, things like that. That way you can tailor the forecast as we get closer in, where the models are a little bit more precise about those key features in the atmosphere. So that's, again, another thing that we're kind of changing our culture here in the Weather Service. Not just Reno, all NWS offices are kind of embracing these kind of philosophies. So in terms of predictability spectrum, typically about a week to two out, we can start talking about big picture trends. Is it going to trend wetter, drier, things like that? This is actually the graph ahead of the October atmospheric river 2 weeks in advance. So actually there's a really good signal that we're going to turn quite wet. And we kind of rode that one to the bank. It ended up panning out quite well. Now, once we get inside that 2 to 4 day period, here's where that transition from being a good statistician to being a good meteorologist starts to pan out, because this is where we get into more of the details of the forecast. Is it going to be a warm storm with flooding, a cold storm with blizzards, a rain shadowed storm, which we often get in the Eastern Sierra with high wind scenarios? That's where that stuff becomes clearer, and we can start communicating those possibilities to folks. Beyond 4 or 5 days, it's really tough to say with any definition what kind of storm it's often likely to be. We can kind of talk about it in general terms, like I will with the forecast coming up. But in terms of specifics, it's a little too soon to tell. Now, in terms of small scale but very important high impact features like rapid snow level drops, intense areas of precipitation, those often are on the order of 6 to 24-hour predictability, just because those features are so small scale that the models do struggle until you get inside of that 24-hour period resolving those features. And sometimes it's not until it's on the radar that we really have a good sense on those. So let's get into the forecast. How about the next 2 weeks? So this is totally random. I went to Cost Plus World Market a month or so ago, and I saw this, and I was like, oh, I got to take a picture of this and somehow get it into the forecast presentation. So these are two energy drinks you could buy. One is the Bob Ross Positive Energy Drink. There's definitely days I could use some of that. And then there's also the Liquid Rage energy drink. Maybe it has double the caffeine or something like that. So are we in for some of these nice little Bob Ross storms over the next couple weeks? Or are we in for some of the Liquid Rage, or maybe some of the Solid Rage if you're hoping for some snow? Well, I think it's actually a mix of both. So let's dive right on in. So what we're looking at here, I'll show it here in a little bit. It's going to be a graph showing you our ensemble forecasts, basically 30 different simulations with showing you snowfall potentials at the Mammoth Airport. Now, of course, the Mammoth Airport is just one spot, so there's going to be some areas that you all know that get a lot more snow than the Mammoth Airport, and there's going to be spots like Bishop that wouldn't necessarily get as much snow, just being lower elevation. Well, here's the graph here. And it's really hard to see if you're far away from the screen, but down here on the horizontal axis are dates. So here is today's Saturday. And then we have our first little series of simulations that are showing some light snow potential around Monday and Tuesday. Now, most of these are just showing like an inch or so, but there's some simulations that are just white, which means they're not showing anything. So there's still a 50-50 shot whether or not the Eastern Sierra sees really any precipitation of note with this first system coming in Monday, Tuesday. It's looking pretty weak. Now, what that storm does do, it breaks down that high pressure ridge a bit, brings some cold air in, and that sets the stage for what looks to be almost a cold atmospheric river type of setup for late in the week next week. And so here we are. This little series of blocks here is Thursday and Friday of next week, so the 9th and 10th. You see a lot of pinks here, which is above about 10 inches of snowfall, again, at the Mammoth Airport. Quite a few of them. So that what that does is it increases my confidence that we could see a storm of some note in the Eastern Sierra with snowfall on Thursday and Friday of next week, just because the percentage of those simulations showing you that outcome is fairly substantial. There's a couple of outliers that keep us totally dry, but nearly everybody has given us some precipitation. And then there's another system out here around Monday the 13th and 14th. Now we're getting into week 2, which is really tough to predict with any definition, but that one's also another one to watch. That one's got a decent moisture tap. There's some other simulations that are showing even more snowfall with that system than the storm for Thursday and Friday of next week. So keep an eye on it. Now, that's one way of looking at it. It shows you the raw data. It essentially implies various scenarios and the likelihood and confidence of them occurring. But what we're starting to do here in the Weather Service is it's called the National Blend of Models, which takes all the models, not just the one you just saw, but everybody, the European, the Canadian, the GFS from the American model, and everything else, puts it all into one blend, bias corrects it, calibrates it as best it can, and it allows us to come up with scenarios and probabilities. So this is a screen capture here of the storm for Thursday and Friday of next week. This top diagram here is showing you the percentiles of snowfall for 24-hour periods. Now, this is for Mammoth Mountain. So mind you, totally different site than the Mammoth Airport. So I wanted to pick a really snowy site. So let's do Mammoth Mountain here. And so as an example, on Thursday of next week, it's showing you the bottom scenario is only an inch. So there's still some models that are showing you not a whole lot, but the top scenario at 90th percentile is 17 inches at Mammoth Mountain. Again, this model, the resolution this far out isn't as good as it could be, so it's going to smooth the terrain a little bit. So the snowfall actually could be substantially more than that. And on the bottom diagram here, it's showing you the threshold probabilities for various snowfall amounts here. And there's a 6% chance of at least 18 inches there for the Mammoth Mountain area from this storm in a 24-hour period. So that's how we interpret that. So this allows us to then communicate this kind of information to partners making weather-based decisions. And you'll start seeing that in our email briefings starting tomorrow. We're probably going to start kicking those out starting tomorrow. So bottom line, it's looking really good for snowfall next week. Keep an eye on Thursday and Friday, and then potentially the following Monday, Tuesday, the 13th, 14th, looking pretty good. And that goes to the 8 to 14-day outlook here. Temperatures near to below normal, which is unusual for us lately. So that sets the stage for some snow, that little bit cooler air, and above normal precipitation on a very broad scale. That Thursday, Friday storm, for what it's worth, could be a very big storm for the Great Basin. The setup is such that, and I'll show you here in a minute, that the moisture may scoot around the southern Sierra and up into, like, say, Great Basin National Park, the Wasatch, a lot of the mountains in Utah. That could be a really big storm for a lot of the Utah mountains, for what it's worth. This is showing you the probability of seeing those atmospheric rivers make landfall, and this is one of the tools that we use to detect those. So we're getting into an active pattern where we see these ARs heading toward us with very high probability levels. That's essentially what you're seeing here, is the percent of models that are showing you these AR landfalls at various latitudes. So it's got those storms there. Here's that one for the 13th, 14th out there. Now, one thing that we do always have to keep in mind is the direction of these ARs matters. If they come in from the west or southwest, that is thumbs up, big time for us. If they come in from the northwest, oftentimes we don't get nearly as much precipitation. They can't squeeze out as much moisture when those ARs hit the Sierra from the northwest direction. It just isn't as optimal. When they hit from the southwest, that sponge gets really squeezed out by that air going up and over the Sierra. So that's where this storm, again, around the 10th or so, late next week, is better for us. You see that these wind vectors are out of the southwest or west, whereas this AR that comes into the Sierra Monday, Tuesday of next week is more out of the northwest, and it's really not going to do as much. So again, this storm here definitely has some good potential, even down into Southern California, and that's where that moisture is going to scoot up into the Great Basin from. So overall, for the rest of December, and we have to take a big step back, 30,000 foot view type stuff, there's really no clear signal on how December as a whole is going to pan out. Right now, it looks like the first week will be dry. The second week could be fairly stormy, but then the balance of December is still TBD at this point. No real clear signals overall from the models for December. Now, what about the rest of winter? We're in what's called a weak La Nina pattern, where the tropical Pacific Ocean is cooler than normal. We see lots of blues there. Now, historically for us in the Sierra, this really doesn't have a huge bearing on us, whether we're in El Nino or La Nina. Lots of scatter. We've had fairly dry La Ninas here, and we've also had fairly wet ones as well. In fact, 2017 was almost a La Nina year. It was officially a neutral zone winter for us, but it was almost a weak La Nina. That was a very big winter. So unfortunately, El Nino and La Nina just don't really matter a whole lot at our latitude. It takes one of the bigger tools out of the toolbox for seasonal weather prediction for us. Unfortunately, it is what it is. Now, the further south you go towards, say, Las Vegas or LA, there El Nino, La Nina has more of a bearing, and La Nina winters typically lean in the drier than normal direction. They'll still get storms, but on average, rolling the dice are a little loaded toward that drier than normal outcome for areas further to the south. So the models are basically panning out with that. Basically, there's an ever so slight lean toward drier than normal for the Eastern Sierra, but my interpretation of things right now is anything is still on the table January through March for the balance of winter. Temperatures, really equal chances. That means there is no screaming signal for a very warm winter. So that could be a good indicator on the snowfall front, that when we get storms, the odds of them being super warm may not be as high as, say, in a typical winter. So that's potentially some good news for us. Here's just if you like pie charts, here's a diagram of the precipitation outlook in pie chart format. It just really goes to show you that any scenario is on the table at this point for the Sierra and up into northern Nevada. So how have these forecasts pan out over the years? Generally, kind of hit and miss in terms of how how skillful are they compared to a roll of the dice. So areas on this map for the December, January, February seasonal forecast, areas that are in blue, it's actually the forecast ends up degrading it over just a random roll of the dice. Fortunately, there are not many. That's good. Areas in orange and red, actually, that's where the forecast actually improves. It is better than a random roll of the dice. So that's good. So here we are, Nevada and a lot of California, and sort of the area in between. That basically means the skill of these forecasts is roughly equivalent to randomly rolling the dice, maybe whipping out the 8 ball at that point. And a lot of that is because of that lack of skill of El Nino, La Nina here at our latitudes. It just is what it is at this point. And seasonal weather forecasts months in advance are roughly where day-to-day weather forecasts were about 20 to 30 years ago. They're advancing, they're getting better, the models are getting better, but there's still a lot we don't understand about how the global atmosphere ocean interactions work at monthly time scales. There's still a lot that needs to be researched on that front. One little quirk though about these La Ninas, especially the weak La Ninas, is that a lot of our high water winters have occurred during weak La Ninas. So this is one little statistical nugget that might, kind of edge me to, if you have any flood concerns or you live or work near a flood prone area, it's just maybe a little extra TLC on flood preparedness going into this winter. By no stretch is a guarantee that we're going to see flooding this winter, but it just, historically, a number of our high water years have occurred during these weak La Nina winters. All right, so I'm going to do some specific winter in the Eastern Sierra forecasting stuff here for a couple minutes, and then we'll wrap up. The fun of forecasting for the Eastern Sierra, I will say, I've been in the NWS in Reno since 2007, and honestly, with every storm that we have, I learned something about how the weather works in the Eastern Sierra. It's just one of those places because of the topography that just the weather always amazes me. It's between the extremes and the distributions of snow and wind and things like that. But there are some fun things about forecasting, and one, you guys have some of the best webcams out there. The Caltrans network is fantastic. The Mammoth Airport, the ski area, the Mono Lake Visitor Center. Just some overall great webcams that we love to use. They're reliable. They work at night oftentimes. And so that really helps us understand what's going on in the area. Also, the number of observations are increasing, and I'll show it on the next slide, but Southern California Edison is adding a tremendous number of weather stations for fire weather forecasting. That has helped us understand more of what's going on in real time. And we've gotten to know, a lot of our forecasters have been here a long time. We know the windy spots. We know the typically cold spots. We know usually where it's probably going to snow the most, but still each storm is different. Now that goes to the humbling aspects of forecasting Eastern Europe, which is a lot. The extreme wind events. I still get amazed at how we know it's going to be windy. The models are showing us it's going to be windy. We'll put out a wind advisory or maybe even a high wind warning, and okay, gusts to 50 or 60, maybe 70 in the wind prone areas. And the front comes through. Usually it's a cold front that does it. And boom, we see 100-mile-an-hour wind along 395. It's like, oh my goodness, where'd that come from? At the same time, like Mammoth Mountain Summit might only be gusting to 120. So how did all that energy get all the way down to the valleys like that? And so we do get humbled by those events, unfortunately, somewhat often in the Mammoth Airport. There by Mono Lake, there, the Lundy Ross fire weather station there, gusting over 100 is not unusual. Snowfall gradients, how much will that moisture will spill over east of the Sierra Crest? How much of it will get into the Owens Valley? How much of it will get into areas along 395? What will the rain snow lines be? Bishop is tricky to forecast for because, how low will that rain snow line get in the Owens Valley? And all it takes is sometimes just a plus or minus 500 feet. And it's a difference between a little bit of rain and a lot of snow for Bishop. And of course, you all know this, the limited weather radar coverage. Now we've improved the Reno radar. It scans at a lower angle, but it's still fairly high up when it gets to points around, say, Mammoth and Bishop. So in terms of winter storms, that it's still tricky to monitor snow squalls and things like that with any definition, just because the radar beam is so high. This is an example on a positive note here of the proliferation of really good wind observations and weather observations from automated gauges around the Eastern Sierra. A lot of this, again, is from Southern California Edison installing their network. And here's a zoom in on Mammoth Mountain. This is actually from the October 25th atmospheric river, showing wind gusts close to 150 there at the top of Mammoth Mountain. So this kind of data really helps us understand the distribution, the nature of winds in the Eastern Sierra, so we can hopefully apply that to future forecasts. Now, staying informed about weather as it's coming here, a couple more slides and I'll wrap it up here. Reading our forecast discussion. So if you're not familiar with it, it's a text product that we issue 2 times a day, usually by 4 a.m. and 4 p.m. It goes through the meteorology of the situation, confidence levels, scenarios, historical context. It's written by our forecasters. You get a little bit of humor sometimes in it. It is a great product. If you had to pick one thing to keep an eye on the weather and read each day, that would be it. So both us and NWS Las Vegas issue these. If you just Google NWS Las Vegas or Reno forecast discussion, you'll find it there. We issue backcountry and avalanche specific weather forecasts that the avalanche centers make use of, but it can be useful for anybody. And I'll show that on the next slide. Social media, both Las Vegas and Reno, we're very active on Twitter and Facebook. We share your all's information as well, just to get the word out there. The Eastern Sierra is a very, vulnerable to extreme weather, big wind events, big snow events, and a lot of people out there traveling on remote roads, a lot of visitors and tourists to the area. I grew up in Los Angeles. I have no clue about snow. So when people from LA are coming up to Mammoth, I understand their predicament. It can be tricky for those folks to really appreciate. So whatever we can do via social media to get the word out there. Always call us if you have questions or if you see significant weather that you didn't expect, because that kind of information can help us. Like, oh wow, we didn't expect that either. So that kind of stuff helps us a lot. I get asked, Chris, where's your app? You guys are the Weather Service. You should have an app. Well, it's one of those things where in the bureaucracy of our agency, decisions were made that basically it's the private sector's role to do application for smartphones. It is what it is, above my pay grade. I would love to have an app. But one thing I will tell you, that if you use an app on your phone for weather information, so if you're looking like temperatures, winds, precipitation, snowfall, things like that, those numbers are likely to be different than what we put out from the Weather Service, from our forecast database, because the app may use their own model, or it may use our data, but then massage it or interpret it with their own algorithm. So there likely are to be differences. If there are big differences, then there's something up in terms of, okay, that would be a time to be like, I'm not sure what's going on here. Give us a call, send me an email. Hey, Chris, what's going on? My app is saying we're only getting, an inch of snow, yet your forecast says we're going to get 6. What's going on here? So just expect differences, just because that data may or may not be coming from the Weather Service. So we do provide a backcountry forecast. If you search for NWS Reno Avalanche, now this just mainly covers the Mono County portion of the Eastern Sierra. It's a summary for the next 36 hours of key parameters, mainly for avalanche prediction, but it can be useful for backcountry enthusiasts who are out there year round. We issue this year round. So if you're like me and running up Mammoth Mountain or something, you want to know what the winds are going to be like, you definitely want to take a look at this. So you search for that, bookmark it. Very useful product. They're issued 2 times a day. We also are starting new experimental avalanche point weather forecasts, and both Reno and Las Vegas are issuing this. This is guidance for specific sites and elevations directly from our forecast database. Kind of complements that backcountry forecast summary that's on the left-hand side of the screen there. So again, this is experimental. If you go onto our backcountry forecast webpage, you should see it, at least a link to the Reno version there. If you have any questions on this, feel free to just follow up with me via email after the presentation. So we also, I just want to note, we do provide support for special events and incidents for public safety partners. We will always relay avalanche warnings that the avalanche centers issue via all of our channels. We want to get the word out there to as many people as possible in these situations as soon as possible. In fact, if there's an avalanche watch, we want to get that word out there while people are in their planning stages of heading out into the backcountry. We do briefings for special events, large public gatherings. If a public safety partner like law enforcement or emergency manager requests it, we can do briefings ahead of time. It really helps us knowing what their thresholds are for an event. Like, ooh, we really can't have winds over 20 miles an hour, otherwise it causes this impact. And that's something we can address, the confidence and probability in those occurring. We also do spot weather forecasts. These are for like search and rescue and wildfires and hazmat. Again, that a public safety partner or an emergency manager might request this, or a search and rescue might request this. These are highly detailed point forecasts. that we can provide. Las Vegas can, NWS Las Vegas can provide as well. And this goes into, this is an example from a lost snowboarder up here near Reno. They were concerned about how low the clouds were going to get because they had helicopter operations. So we addressed that in the spot weather forecast. So that is what I got. These are just some summary points from mainly the weather outlook presentation. This way, basically be prepared for anything. Right now, it does look optimistic for snow in the area for next week, especially late next week into the following week. So roughly the 9th through the 15th seems like a window for us to pick up some snow. Just like anything in the Eastern Sierra, nothing is set in stone at this point, but our confidence, our optimism is gradually increasing. So hopefully that is a sign of things to come for the rest of winter. And that's it. My voice could use a break. Any questions?
Thanks, Chris. I'll try and relay it if you can't hear them, Chris.
No worries.
So I listen to my weather radio every day. Somebody come up and talk to them up there, or what? Can you hear me?
Barely, unfortunately. Sorry.
Come on up.
So I have a weather radio that I listen to every day, and in Bishop, it comes from the feed out of Las Vegas. It doesn't come from the feed in Reno. Where is the cutoff for those two? Should I be trying to tune into a Reno to get the ski forecast for the Eastern Sierra? Is that going to be more accurate? And can you kind of discuss how you guys share information and everything too, please?
Yeah, no, thanks for the question. The Bishop Weather Radio is an interesting one because it is operated by NWS Las Vegas in terms of the content that's on there. But oddly enough, we actually maintain it just because it is easier for us to physically get down there to maintain the transmitter. In terms of information where the weather radio cuts off, there's a transmitter up on Conway Summit, so north of Mono Lake, that does reach down into parts of southern Mono County. Now, depending on where you live, you may or may not be able to receive that frequency. And that's the one that would be coming out of NWS Reno and would contain forecasts specific mainly to the Mono County portions of the Eastern Sierra. So you'd have to, if you just Google, NWS Weather Radio, and you can find coverage maps, look for that Conway Summit transmitter, and then there's a frequency there. That would have information more for Mono County, whereas the Bishop one's going to probably focus more on northern Inyo.
Cool. Come on up.
Hi, I had a question about soil moisture content. This is kind of a related question, but these fires, I didn't realize you guys measure moisture in the soil. But these fires now have gotten so big and so hot, I'm wondering how much of the land is getting sterilized. And I mean, can you talk about the effect of these fires on the soils and sterilization? And
yeah. No, thanks for the question. So yeah, these fires, it's just, it definitely, the last 2 years just seem like it's never ending. 2 years doesn't make a trend though. So, hopefully we can get a decent winter and we can kind of at least put a pause on these giant fires, at least in the mountain areas. But what the fires do when they burn really, really hot, and those are what we call plume dominated fires, like the Creek Fire, the Caldor Fire, the Dixie Fire, where they put up those almost nuclear bomb looking plumes. Those are the ones that are burning so hot that essentially they're cooking the soil, where it creates what's called a hydrophobic layer. And so it's a lot of the waxes and debris from the stuff it's burning comes on top of the soil, and it creates an impermeable layer where the water cannot get into the ground. So if we have heavy rainfall events, instead of going into the ground like it should, it just runs right off. And that's where we have the flooding and debris flow issues there with that. So really near any of these recent big burn areas like that, flooding is an increased concern. The trigger for the catastrophic floods, like the debris flows where you have the giant boulders and mudslides and it obliterates communities and things like that, you really need a short duration, high intensity rainfall that just overwhelms the entire ecosystem, and that water, there's so much water coming in such a short period of time, just runs right off and starts carrying boulders and everything else with it. Generally, over roughly an inch an hour is kind of the threshold we look at. Now each burn is different. It depends on the steepness of the slope and how severe the burn was. And there's folks from the Forest Service and the Weather Service that go out there and actually analyze that and run models and things like that. So we have all that information. We use that to issue flood warnings. So really, it's all about those short duration, high intensity rainfalls that cause the flooding issues on those burn areas. In terms of that, the effect on soil moisture, that's starting to get a little beyond my area of expertise. The soil moisture I was talking about earlier is measured at the SNOTEL sites, which are those snow pillows that measure our snowpack and things like that. So I can't necessarily speak to how the burns affect soil moisture underneath it, except to say that typically it repels water and it just sort of runs right off into the creeks.
Cool. Thanks, Chris.
No worries.
In your opinion, we were discussing this last time. Does it seem like in your opinion the seasons are getting later? It seems like summer.
Can you say that again? Sorry, I did miss that.
It seems like seasons are getting later. To me, it seems just recent years. Summers are
Yeah.
extending in January. We've got big storms in late May and June here and there. And it just seems like that's kind of becoming a trend here, and at least on the West Coast. You guys notice that any kind of trend of like seasons going later?
So, how would I say this? So, subjectively, yes, I seem to have seen it. Yeah, because it's just like it seems like falls are drier, and it's like we're waiting later to get these storms, and then spring, it's like winter doesn't quite let go. And so March ends up being really big. We've had some decent Aprils and even Mays. Just when most of us are ready for summer to show up, it's like, no, never mind. Memorial Day's a washout. It's snowing and everything like that. So, yeah, I hear you on the season shifting thing, because I perceive it as well. It seems that way. Now the data, I've done some number crunching. There doesn't seem to be a long-term trend toward that if you're looking over decades. The one exception to that statement is some research that has been done recently by others has shown that the first storms of the season in the fall are trending later and later in California and into Nevada. And so that is a real trend that it's been shifting more of the storms from October into November in terms of the first storms of the season. That's why I was so happy to get the one we did in October. I was like, okay, good, at least a little bit earlier than previous years. So I think I hear you, and I share your feeling of that. Yeah, it seems like springs are more volatile than they used to be and wetter. But I haven't seen any compelling long-term trend data to show that, except for that later first storm in the fall.
Very good. Anybody that has questions out there in the virtual world, feel free to drop them in the chat. I'm sure Chris can follow up with you on there if that's okay. Yeah, in fact, what I'll do is I'll put my email in here now. It's just my schedule and everything. Probably good to just shoot me an email if you have any follow-up questions. Cool. Chris, thank you very much for tuning in again today. We appreciate it. And it's always good to have you here. No, thank you for the